So we are learning about word2vec. So word2vec is a technique of generating word embeddings where we convert words into numbers, right? That's the simplistic explanation. So so for example, if the statement is, let's say, I ate apples, so this can be represented as I eat apples. So this will be represented as some array of numbers or some vector like this. Similarly, and this is the number of dimension is usually about varies from 100 to 512, which is the length of the array. So this is how we are going to represent, right? Each word by the n-dimensional vector. So in word2vec, the basic technique that is used to represent word as number is based on the principle which is known as you shall know by the company you keep. Okay, so basically each word is represented by the nearby words where it occurs more frequently. For example, let's say king and queen stay in palace, right? So if you take a look at this word, for example, king and queen, obviously they occur most often together, and palace also often more often together with respect to king and queen. So queen will be represented by the vector of queen and palace, whereas king will be represented by a vector of queen and palace. So this is called representing word by its nearby words is known as the word2vec, and there are two popular ways in which we can do this. One is called continuous bag of word, and second thing is called skipgram, and we'll learn about each one of them soon. So let's understand one of the technique that is used in word2vec, which is known as continuous bag of words. Okay, so in continuous bag of words, we predict missing word from a given context. Okay, so for example, let's say if you have a sentence like I live in California, which is capital of United States of America, right? So this statement may or may not be true, but we are just taking an example. So in this example, what we do is we mask this word. So let's say capital. Then we represent a training example in which, say, we have input called I live California, USA, and the output is capital. Right? So we just define a training example like this. Okay, and then we train a neural network where we say there are multiple word inputs. So let's say this is one, this is, let's say, input, this is, let's say, word I, right? This is a vector for word I. Then let's say this is the vector for word leaf, and so on and so forth. And this is the vector of word California. Then we create a neural network, right? uh, like this. Similarly, we connect all the layers, and then we again do another layer, and this we say the output in this particular case is capital, right? So we feed the neural network this example and then recompute weights at each layer, and these layers are this W1 and W2 and W3 at each layer. Those are known as these weights are known as the word embeddings, right? So basically what they do is this, this is an equation which of this type WTX plus B, right? And we are learning these weights. This we already know from the input, and this bias also we learned. Initially we initialize this with random values, and then we compute the difference between y hat and y, back propagate the errors as we saw in the example of deep neural networks, and try to minimize error between this output and the predicted output. And in the process of this we keep adjusting these weights and bias, and these weights and biases are known as word embeddings. Okay, so in case of continuous bag of words, you predict the missing word from a given context. So you present the multiple words as input, but you just compute one output. This is called CBOW, or continuous bag of words. Then there is another technique which is called skipgram. So skipgram, it flips the continuous bag of words on its method. So here let's take example of same example where I live in California, which is capital of USA. So in this example we will feed capital as input. So this will be my input, and the output will be, there will be multiple outputs. So the input is capital, output is California, output is USA. For given a word, basically it tries to predict the context. That is what the skipgram does. Then given a context, present I, right? Here again the input is only one, which is the vector of capital word, and then you have multiple neural networks where again something like this. There are multiple outputs in this particular case, one for each word. So this will be output of word USA, this is the output for word I, this is the output word for California, so on and so forth. Okay, so this is a reverse of a continuous bag of words. So in this process also we compute predicted output with the actual output, adjust the weights to minimize the errors, and then these words and vectors known as are being used as embeddings for this particular word. Okay, so this is how we represent word as a vector using word2vec. We can use either skipgram or continuous bag of words.